So we are going to discuss it in detail over here. Okay. Now I'm erasing this side. Nature of emission of alpha, beta and gamma. Nature of emissions first for alpha emission. You know, alpha is basically the nucleus of helium, or you can say the nuclei of helium. Alpha is represented by this symbol. Alpha is doubly positive charge, right? As helium atomic number is 2 and atomic mass is 4. Okay, alpha is what they are, helium nucleus. Alpha has doubly positive charge. Okay, now what is beta, or what is beta emission? Now let me discuss an example over here. For example, if from an element alpha is released, look, for example, we are having X an element, right? And it has atomic number Z and atomic mass A. If it releases alpha, new element will form, and the atomic number of that new element will decrease by 2 and atomic mass will decrease by 4. Why? Because helium has atomic number 2 and atomic mass by 4. So we can say that if any element we are having X whose atomic number is Z and atomic mass is A, if it releases alpha, so new element will form and atomic number will be decreased by 2 and atomic mass will decrease by 4. And over here alpha will be emitted. Okay. Now coming towards what is beta emission. What is beta emission? Basically, beta is showing you a single electron. Beta is showing you what? A single electron, and beta has a negative charge on it. Okay? Beta or electron. Electron has just negative charge on it. For example, if a certain element releases beta, for example, we are having a certain element X, atomic number Z and atomic mass A. If it releases beta, so new element will form. Do remember, electron has no concern, nothing connection with atomic mass, so the new element's atomic mass will not change. Now, atomic number of that new forming element will increase by 4. Why? Because loss of electron is shown by a positive sign. So positive 1 will be written over here. If certain elements releases single beta element, or you can say particle, so atomic number of that element will be like +1 over there. We will add +1 over here because loss of electron shows you what? Plus is shown by a plus sign. Okay, and that is beta emitted or released beta. Okay, beta is what? Beta is only showing you a single electron, and loss of electron is shown by plus sign. So if from an element beta is released, so its atomic number will be increased by only 1 plus 1, and atomic mass will not change, because atomic mass definition is the sum of protons and neutrons in the nucleus of an atom. There is no connection of electron with atomic mass. Okay. Now coming towards gamma emission. You know, gamma is shown by this sign. Symbol. Gamma is not a particle. Gamma is showing you just an energy. It is in form of electromagnetic wave. Gamma is not a particle. Gamma cannot make any new element. Okay, like in the first two cases we are forming over here a new element, but the case of gamma is very different. Gamma is not a particle. It is an electromagnetic wave which is in form of energy. So gamma emission from an element can only convert the element from unstable state to a stable state only. It cannot form any new element. Okay. For example, we are having an element X with atomic number A, atomic mass, with atomic number Z and atomic mass A. Over here the same element we will form. Over here new element will not a new element will be formed and gamma rays will be released. But do remember, initially it was unstable, but now it will become what? It will become stable. Okay, initially it was having a star on it. Star or steric shows you instability. Now the same element become what? Stable. Okay, this was the emission of all these alpha, beta and gamma. Okay, and now discussing with relative ionizing ability and relative penetrating ability. I'm erasing this side. Relative ionizing ability and relative penetrating ability. Relative ionizing ability and relative penetrating ability. Okay, you know, relative ionizing ability of, if we compare the relative ionizing ability of alpha, beta and gamma, so we will understand that relative ionizing ability of alpha is greater than beta and beta is greater than gamma. Means alpha's ionizing ability is very greater, beta ionizing ability is intermediate, and gamma ionizing ability is very less. What is ionizing ability? The phenomena or the process in which electrons are ejected from the outermost shell of a certain element is not known as ionization. Okay, so if we compare the ionizing ability of alpha, beta and gamma, so we will write alpha greater than beta greater than gamma. Now coming towards the relative penetrating ability, if we compare the relative penetrating ability of alpha, beta and gamma, so we will understand that gamma's penetrating ability is very greater than beta, beta's penetrating ability is very greater than alpha. Okay, means beta can be penetrated into very deep and gamma can be penetrated into very deep, beta can be penetrated up to intermediate level, and alpha can be alpha's penetrating power is very less. If we see the diagram or here figure 18.4, page number 239, page number 239, and if we see figure 18.4, if you see figure 18.4, it's very clearly shown over there that alpha even cannot pass through a paper, while beta can pass through a paper but cannot pass through the aluminium foil. Gamma can pass through paper also, aluminium foil also, and lead or concrete or there till it can reach over there. Okay, clear? Okay. So this was all about today's lecture, and let me summarize today's work. What we have done in today's lecture, we have discussed about radioactivity. We have discussed what is radioactivity, what are radioactive elements, what are the natural radioactive elements, which are artificial radioactive elements, and then we have discussed that whenever we have discussed an experiment over there, that when a radioactive sample is placed in an electric field, what kind of behavior it shows and what sort of rays or what sort of particles it releases. Whenever radioactive sample is placed in electric field and magnetic field, what kind of behavior it shows, what kind of particles it emits, and what is the nature of it, right? Okay, then we discussed nature of emissions of alpha, like alpha emission we have discussed beta emission, we have discussed gamma emission, and we have discussed also relative penetrating ability of alpha, beta and gamma, and we have also discussed relative ionizing ability of alpha, beta and gamma. So this was all about today's lecture.